Hello all, welcome back to the second video of this series. This video is primarily focused on chapter 2 of the computer science syllabus in 12th standard. If you haven't watched my first video which covered the first chapter of unit 1, please do go back and play it. Let's move on to see further details of the chapter number 2. So as we spoke last time, the unit 1 is about problem solving techniques, and in video 1 you would have seen more details about what is a function. Just a recap about a function one more time. A function is a basic element in any programming language. And a function is comprised of multiple subroutines. And a subroutine is a code which helps to perform a simple task. Multiple subroutines form a function, and one or more functions will become a particular programming language. And a programming language is obviously linked together by algorithmic statements. So without functions, a computer program normally cannot perform and give you the output you need. Okay, let's talk about data abstraction now. So in data abstraction, we are going to see more details about what is an abstract data structure, what are abstract data types, which are also called as ADT. In your book, you would have seen examples of them, and good examples related to abstracts, and an important concept called pairs. And last but not least, some more examples about the abstraction structure as well. Okay, so what is an ADT? So before we go into the ADT, you need to understand the basic simple English meaning for an abstraction. Abstraction in general is always about giving an overview of things or hide all the details of a particular topic. Okay, so similarly in computer world, the process of only providing essentials and hiding the rest of the details is an abstraction layer. So normally data abstract allows any type of programmers to treat the code as objects, because as we spoke in the past, without an object you can't declare a class. An object in our real life example could be a car, it could be a book, anything it's treated as an object in English word is also can become an object in computer worlds. Now abstraction also helps in splitting a program into many modules, so which helps to actually reduce the length of some of the programs, because you can't be writing code in a computer world like million lines of code in one go, where it's really hard to read for a developer. So it is important to cut into different modules, and hence abstraction type of techniques help to build that modularity. Now, another word, it is confusing sometimes when you talk about classes and an object and then an abstraction as well. Ideally, class itself is kind of an abstract layer. Okay, even though it is comprised from or derived from objects, a class itself is a representation of some abstract data types, which we are going to see what are those soon. And they are called as ADT. It's a nickname. So sometimes people use this word differently. For example, in ADT is generally not used if you go to computer job, but when you say a class, people quickly understand it. That's how the real life is. But when it comes to your books and stuff, you still need to understand, okay, there is a concept called abstract data type, and hence it is important to learn the definition of it. So ADT is, again, I'm repeating this, it's a type for objects, or you can say it's a class for objects whose behavior is defined by a set of value and set of operations. We're going to see more examples that will make you understand what does that mean. But for now, it is important to memorize the definition of an ADT. The definition of ADT only mentions what operations to be performed, right? For example, let's say, as I spoke yesterday or in the other video, when you're doing an operation such as an addition, 1 plus 2 is equal to 3, ADT helps to define those operations, but it doesn't care about how these operations get done. And the done word is the terminology we use in computer field is implementation. So it does not also specify how a data will be organized and processed in memory and what algorithms will be used for implementing those operations. So how come then computer intelligently does all those? That's the magic. You will learn more as you grow. But coming back to ADT, it is important to understand a class and objects and /ADT, because without an ADT, you can't anyway define what actions what operations are to be performed. We have to define. For example, you need to say you need to do addition, 1 plus 2. How it is performed? It's some other components problem in the computer. Okay. The picture there is just a very high level picture. I don't think you're going to learn in depth of each of those, but it gives you an idea, like when your program is executing, it looks at, all right, what are the data types here? What are the objects defined there? And what data is sitting in those objects? And whether the data is passed through a variable or an expression, etc. And after that, the compiler, along with memory and algorithms in the computer, manages the implementation. Hope that gives a little bit of overview of ADT. And I move to the next slide to discuss more examples as well as different types of ADT. So ADT types are 3. They're called list, stack, and queue. Again, in your books, not every item has been discussed in detail, but it's still good to understand the types it has and also understand the examples related to them. You would have used some of the commands you see on the screen in your programming, but there is obviously hundreds and hundreds of commands in any programming language, especially even in Python too. But these types, for example, in this best example is, I would say get, very simple. If you use a get command and give a position in it or a variable in it, it knows that it has to return an element from a list given at any given position. We are going to see more examples of list later, and that will give you more clarity. So the rest of the commands are also used in day-to-day life. For example, insert command, remove, size, is empty, is full. But what I'm trying to say here is these are predefined types which are already there, which helps a programmer to simply use it and then perform the task they want to do to get the required outcome. when you go into programming type of job in one day, you will learn all these things, and the more you use these commands, you will get more experience, because not from day one everyone knows everything. It comes with practice and constant use of these commands or the data types as you do any programming. Okay, let's move on to the next topic about the constructors and selectors. So it's almost a continuation of the last slide. The terminology used to get the record information we need during programming are called constructors and selectors. So if there is a question about what are the two types of functions that are required to facilitate any data abstraction, again I repeat, data abstraction is going to help you to get the data what you want to perform your required operation. So constructors are nothing but those functions, and you can see the word functions. As I said, without functions nothing happens in a programming world. So I repeat, so constructors or functions that build the abstract data type. So an example here is, okay, you have declared a city equal to make a city of name, comma, latitude and longitude. This helps to build the structure of the data itself. Once you have defined this, then you can easy to get the data. So in order to get the data, that's where you use selectors commands. So selectors are functions again that retrieve information from a defined data type. So in the above example, we have already defined a constructor called city, which is formed abstract data type. Now from there, if you want to retrieve or you want the information from about the city, example, you want the name. So you can use the command for get name of the city, and you will get the answer. Same way, if you want, let's say that city is, you may be passing a value of a city at one point as Chennai, and you may get the name as Chennai as an answer. Similarly, get latitude, it will find you the value of a latitude, and get longitude as well, you will get the answer. So first letter should be lowercase g. And another simple example, this is more a mathematical constructor to find a rational value, and we've constructed a n comma d, but the main thing here is when you perform a numerator by denominator operation, it knows to substitute the value correctly, 8 in x value divided by 3, and get you the correct answer as well. Now I think with this you would have got an idea. Really, it's very simple concept. Basically, you have to define an abstract data type, which is nothing but almost similar to the class and object concept we discussed in chapter 1. Now, as we deep dive into this, the concept of pairs is also important, because when you expand and the way how you define a structure, there are different ways of defining it, and how a computer program will understand that as well. So in your book, this has been introduced, and the definition of a pair is important, definition of a list is important, and also tuple is important. So any program normally consists of two parts, which I said before. It will basically the part that operates an abstract data, and the part it defines its representation as well. So to enable the concrete level of data abstraction, Python, like programming language, provides a compound structure, meaning a combined structure, I would say, which hold two pieces of data together, called pair. And what is that? How does it look like? The common method which is used to bundle these two values into one can be considered as a pair. The way they have defined the pair is again two types. It can be a list or it can be a tuple. So list is again a form. It's a kind of it's a format how you define how the structure of the data. The main element in a list is it is constructed by placing expressions within a square brackets, and it's separated by commas, and it can definitely store multiple values. Like in the example, you can say 10 comma 20 and if you wanted to find what's the value of a list, you can use list in the bracket 0, which gives you answer of 10, and if it lists 1, it gives an answer of 20, and you can print those values as well. These are some standards for Python, I guess. It's more specific to this language, and obviously the concept of list could be completely different in a different programming language, which is important for you to understand. It's not universal standard. Same way, tuple. Tuple is almost similar to list, except you cannot change the elements of tuple once it is assigned, whereas in a list, elements can be changed, and also it also uses a parenthesis. You can see the brackets are different. That's, we call them as brackets, right? That's the main difference to distinguish both of them. And tuples can also store multiple values in a single variable and can be declared using parentheses too. So normally both are used in the programming world, but mostly list is used because it's quite common practice, but based on the need, tuple is used. Okay, so this particular slide, the main thing for you is to understand the difference between list and tuple, and able to define what is a list, define what is a tuple, and give an example. So if you're thorough with that, that will be good enough. Okay, so the next one is I've given some examples in next two slides to explain the concept more. This first example, which is a class construct of a person, was in your book, and it is a great example of a multi-part data representation. What does that mean? When you talk about a person in general, a human being, you will have multiple items of a person. If you think about their names, for example, or their date of birth, right? If I say as a student, for example, you will have a name, first name, last name, date of birth, address, and phone number. So you can add more and more to it, and that's the kind of example object is called a multi-part data representation. In this example, creation is a function they've declared to create as a new data type, and then all the first name, last names are variables, like normal. And you can do quite number of print statements or calculations, etc., using that example. So I haven't given the full examples because you can read it from the book. So, and two more examples about the tuple, and also sorry, I forgot about the other one. I'll go in the next slide in a minute. How do you calculate the length of a tuple? I wanted to show a difference between this one and the list. So in this screen, you're looking at the bottom, the black color screenshot. You can see that there is a tuplex is just a variable. It's been declared, and as a tuple of T3SO, and then is a print command of tuplex. It's just again you're printing it, and after you print it, it can print T3S0. You can try it out in your lab. But now when you use a length function to know the length of a tuple, and when you print that length, you will find the answer is 4, because it has calculated the length of a T3SO as 4. But when you go to the next example, when you compare this with, compare the other with the list, and I've shown you two different examples. The first one is got greetings. You can see three different words: hi, hello, and what's up. And when I do a length of this, the answer will definitely come as 3. Okay. And in the bottom example of the shopping list, when I do a print of this, you will see answer as 4. What's the difference between the other one and this? Almost looks similar, isn't it? But there is a difference. You can understand that in each of these examples, when you look at the variables, even in the bottom one, apples, bananas, carrots, and chocolate, each one has got multiple elements. Apples has got already 1, 2, 3, 4, 5, 6 letters. So it's a combination of multiple sub data into it as a single and treated as a single data element um, in a list world, and hence list can be used for some of these complex calculation as well. Hope that is helpful, and I've just ordered an index is equal to n minus 1. It's just for you to understand that there is a cursor position for each of these items. For example, if I want to get just apples from the shopping list, I can just do a get of 0. That's the first position. If I want to get bananas, I need to say get of bananas. So the way computer sees their position in the array is 0, 1, 2, 3. Yeah, so just wanted to explain that, and hence I added an n minus 1 example there in the above screenshot. Okay, I hope that is useful and clear. And with this, I'm come to the end of the video, and I hope this chapter was easy to understand. I request you to add any comments and suggestions if you want me to focus on certain topic more. And soon I'll be posting the chapter 3, which is about scoping. Until then, you all have a good day. Take care. Bye.